Okay, let's start with kinematics, and we'll define acceleration A. So A is acceleration, and we're not dealing with vectors at this point because we're just moving in one dimension. And V is the velocity or speed, doesn't really make a difference at this point. And they're related by definition in that way through a time derivative. And then we'll define the velocity in terms of the derivative of the position. And so we're imagining moving in one dimension. X is position or some distance in the horizontal direction, if you will. So the complete motion of an object that experiences an acceleration is going to be obtained from these definitions. So let's say we have the acceleration of an object and it's a known quantity, it's a constant, let's call it A naught. Okay, so we know that A naught is equal to dV by dt, and so we can integrate both sides in time to get V. Right? So we'll get A naught times t, because A naught is a constant, but we have to add a constant to the result, and it has to be a speed because this equation is about speed or velocity, so it has to be something we call, say, V naught. And physically it represents some initial speed, right? So at t equals 0, v is of course just v naught because a naught times t is 0, so v naught is the initial speed. So now let's, given this, let's go and see what the position is, right? So by definition, velocity is related to position. By that, we know what the velocity is. It's v naught plus a naught t in this case. Okay, so it's a function of time, and we need to write it out completely as a function of time. Now we can integrate both sides in time. Right, so we'll integrate v naught plus a naught t in time, and that'll give us the position. So the position x is equal to, we have v naught t plus, right, the integral of t is t squared over 2, so we get 1/2 a naught t squared, or we have to add an integration constant, and so we'll put it over here, and of course this is about position x, so we'll put an x naught, and we can see that at t equals 0, x reduces to x naught, and so x naught is the initial position. And so what we get is that an object that experiences a constant acceleration, a naught, changes its position depending on the initial speed v naught and the acceleration a naught.